In this video, we will be discussing about best sightseeing pair. You are given an integer array values where values of I represents the value of ith sightseeing spot. Two sightseeing spots I and j have a distance j minus I between them. The score of a pair I less than j is values of I plus values of j plus I minus j. The sum of the values of the sightseeing spots minus the distance between them. Return the maximum score of a pair of sightseeing spots. So what they are saying is that in the input, we are given an integer array values, right? Now we need to find out the maximum score of a pair of the sightseeing spots. So basically, what they are saying is that if I have two elements at index I and j, where I is less than j, right? Then if we apply the formula that values of I plus values of j plus I minus j, right? This is the formula where I is less than j, right? So for any pair inside this values, right? Whichever pair is giving you the maximum value for this formula, that maximum value is your maximum score and you need to return it as your answer, right? So let us suppose my I is here and j is here. So in this case, values of I is 8, values of j is 5, I is 0 and j is 2, right? So what will be the value? 8 plus 5, 13, 13 plus 0, 0 minus 2. So this will be 11. And this is the maximum value that you can get for any pairs inside this values array, right? So now how are we going to solve this? So one simple naive or brute force is that I will take into consideration each pair of the values array and then I will apply this formula and find out what is the maximum value, right? So if I try to write the pseudo code for that, so what I will do is I will take a variable max score, which will be 0 initially, and then I will run a for loop of I starting from 0 till n, right? Then we'll run a for loop of j starting from not 1, from I plus 1, right? Till n, right? And then inside this, in the max score, you will update it to the maximum of max score, comma, this particular formula, values of I plus values of j plus I minus j, right? And then at the end, you can just return this max score, right? So this is the pseudo code for the brute force. But since now we are taking into account each pair inside our values, this is running n times, this is also running n times, right? So our time complexity has become order of n square right now, right? And given the constraints of the problem, the maximum size of the values vector is 5 into 10 to the power 4. So n square won't work over here. So we will have to think of something else. So now how do we optimize this? So let's remove this. How are we going to optimize this? So see, this is our equation, right? Where what are we doing? Values of I plus values of j plus I minus j, right? So if I see, although there are four things over here, but if I look closely, then there are only two things. One is I and one is j. At one place we are using their value and at other place we are using the index, right? So let me just rewrite this equation as values of I plus values of j minus j, right? So now I have combined all i's together and all j's together, right? So now how is this going to help me? Now I can treat this as one expression, right? I can denote it with, let's suppose, x, and then I can denote this with y. So I would have to solve only these two, right? So now, if I say you that, okay, n squared is not working, so we will have to think of something about n log n or n, right? So if this is my expression, right, and if I fix this value, right, if I fix this value, then I will have to identify this value, right? If I am fixing this value, this I am fixing, this is fixed, right? So now I need to identify that what should be the corresponding i's value, right? So see, eventually we want to maximize our value, right? Whatever is the value of this entire expression, that has to be maximized. So if I have fixed this value, then whatever is this value, that should be the maximum so that I can maximize my score, right? And other thing that we have to keep in mind is that I should be less than j, right? So at whichever j I have fixed this, let's suppose my j is at 2. I have fixed this value at j equals to 2. Then for finding out this value, I just need to find out that whatever are the elements to the left of j, basically these many elements. For these many elements, for all the indices, what is the maximum value for this expression? And whatever is this maximum value, that I will consider for this particular j, right? So this is what I'm saying. If we are fixing this value and we are taking the value of this expression towards the left of j, and we are also taking the maximum value, then whatever is the value that we will get for this expression for that particular j, that will be the maximum score, right? So if you find out that maximum score for all the j's, right, then you can take the max of all of those, and then you will be able to identify what is the final maximum score of any pair in this values array, right? So if I remove this, so this is our array, right? So as you know, j will always start from 1, right? Because if I'll start from 0, I don't have any I to consider. So j will always start from 1, right? So now what I can do is, for every j, I want to know that what is the maximum value of values of I plus j towards the left of it, right? So basically, let me just move this a little left. So now, if you see over here, if I try to find out this value, values of I plus I for each of the index. So what I will get, this will be 8 plus 0, that is 8, 1 plus 1, that is 2, 5 plus 2, 7, 3 plus 2, 5, and 6 plus 4, 10. So this will be the array. Now I need to find out the prefix maximum, right? Basically, for each index, I want to know that from the starting till that particular index, what is the maximum value, right? So for that, what are we going to do? This is the prefix maximum. So here, first element will be copied as is. Now for the second element, we have to compare the value that is present at the current index and the previous value in the prefix max. So out of these two, 8 is greater. So we will have 8 here. Then out of 7 and 8, 8 is greater. Out of 5 and 8, 8 is greater. Out of 10 and 8, 10 is greater, right? So this is my prefix maximum array. Now, for each of the index, we have the maximum value of values of I plus phi, right? Now, simply what we can do is that we can start our j from 1 till n, and we can identify the values. So this is index 0, 1, 2, 3, 4, right? Now, when my j is 1, I will consider the value for I at index 0, right? So, values of I plus I, this value will be 8, right? And then values of j minus j, this will be 1 minus 1, right? So, that will be 0. So, the value of this expression will come out to 8. So, the max score right now would be 8, right? Then you would move your j to 2. So, for j equals to 2, the value for I would be this one, j minus 1, right? 8. And then let's calculate for 2. So this would be 5 minus 2, that is 3. So 8 plus 3 will be 11. Max score will become 11, right? Then j will become 3. For 3, we will take j minus 2, that is this. So value for I would be 8. And then for j, it will be 2 minus 3, that is minus 1. So 8 minus 1 is 7. Max score is already 11. It won't get updated. Now j will become 4. So for that, again, i's value will be 8 only. Here it will be 6 minus 4, that is 2. So 8 plus 2 will be 10. Max score is already 11. It won't get updated. J will become 5. We will move out and we will stop here. And this is the maximum score that we have got for this particular example, right? So this is how we are going to solve our problem, right? We will create a prefix max vector, right? The first value we will copy as is, and then from the next value, what we'll do is, first we will apply the formula values of I plus I. We will get this number, and then we will take the max of this number and this number. Then whatever is the max, we will keep it here, right? Then we'll start a loop of j from 1 till n, and then we will consider prefix maximums j minus 1th value plus values of j minus j, and we will take the max of it in the max score, right? So let's quickly look at the code. So first of all, let's take the size of the vector values in n. Then let's create a vector for our prefix max. So let's name it pre. Its size will be equals to n, and at the first index we will copy the value of values vector, right? Now let's take a variable max score for finding out our answer, and then we'll run a for loop of I starting from 1, I less than n, I plus plus. We have started from 1 because for the 0th index we have already copied the value into the prefix max vector, right? So now we will first find out the value. So it will be values of I plus I, right? And then in the prefix of I, we will have to keep the maximum of prefix of I minus 1 comma this value x, right? So with this, we will be able to populate our prefix vector. Now we need to run a for loop of j starting from 1 till n, and then we'll do j plus plus. Inside this, for the max score, we will take the maximum of max score comma the expression. The expression will be prefix of j minus 1 plus values of j minus j, right? And at the end, we can return this max score. So let's run this. Now here if you see, we are running one for loop till n times and another for loop till n times, right? So here the time complexity is order of 2n, right? And what about the space complexity? So here we have taken a vector prefix, right, for storing the prefix maximum, and its size is equal to n, right? So the space complexity here is n, right? Can we reduce it further? Can we optimize our space complexity? Can we eliminate the need of creating this prefix maximum vector? So see, when I am finding out our maximum score, can't I calculate the prefix maximum for each j on the fly? So see, if I am taking a variable left score, so this left score is denoting that what is the previous max i's value. Basically, this prefix of j minus 1 that you are considering, I am going to replace it with the left score, right? So now initially the left score will be equals to values of 0 as we kept it for the prefix array, right? So left score will be values of 0. So when you will enter this for loop, then for j equals to 1, it will consider the previous value, right? See, ideally it was values of 0 plus 0, but plus 0 is not going to make any difference. That is why at both the places we kept values of 0, right? So it will consider the left score, and j's value will be considered for index equals to 1, right? Now, for the next index, when j equals to 2 comes, before that, our left score should now consider the left max score for index 1 also, right? So here what we will do is, in the left score, we will update it to the maximum of left score, comma, values of j plus j, right? And we will remove this, and we'll remove this as well, right? So what we did was that we are calculating the previous maximum left score in this variable. So initially it is equals to values of 0, right? Then we are calculating the max score by considering the left max score and the value that we are getting for j, right? Then we are updating our left score with the current index so that it can be used in the next j's index, right? So consider this. This is nothing but I. Since we have taken variable j over here, that is why we have written j. But this is the expression for I. Values of I plus I, right? This will be values. So if you see here, let me run this. So now we have only one pass. We are running only one for loop n times, right? So the time complexity is n. And we have not taken any extra space. So the space complexity is constant, right? So let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.